All right, so these last few examples, all right, for number 2 here, we're going to find the asymptotes, intercepts, domain range, and graph it. So I started it for you. I factored the numerator and the denominator, okay? There's nothing that cancels out, right? And so that means there are no holes, okay? The vertical asymptotes come from these factors in the denominator, right? So that's going to be x equals 1/3 and x equals -2, right? So 2 vertical asymptotes here. The horizontal asymptote, I'm noticing the degrees are the same, right? So remember, we're going to look at the ratio of the leading coefficient. So that's going to be 1/3. So y equals 1/3. Okay. I'm going to draw in those asymptotes real quick over here. All right. So those are my asymptotes. So for the y-intercept, right, that means x equals 0. Okay. Now, when I plug in 0 in for the x's, okay, because the numerator is x squared minus x, right, that's just going to be 0 minus 0, which is 0 in the numerator. And so the denominator, it doesn't matter, right, because 0 divided by anything is going to be 0. So your y-intercept is at 0, 0. Okay. For the x-intercept, we said that means your y is equal to 0, right? And if you recall from a previous example and in the other video, we said we're going to set the numerator equal to 0, okay, to figure out the x-intercepts. So this one, this factors to x times x minus 1. And so we have x is equal to 0 and x is equal to 1. So there's actually 2 x-intercepts then, at 0, 0 and at 1, 0. Okay? So at 0, 0 and at 1, 0. So this asymptote is 1/3, so I'm going to make sure that I draw it over here. Okay? Well, that's kind of weird, right? Like, what's this graph going to look like? Okay? Well, we're going to see here, okay? So I'm looking at this x-intercept of 1, right? If, so this is in this region where you can see I'm kind of circling. So I'm going to draw something, oh my goodness, sorry. So I'm going to draw something like this, okay? All right. Now, I don't want you to automatically assume that the other one's going to be here, all right? And then we're gonna figure out what goes on in the middle here. Okay, so sometimes what helps is if you take a point, like let's say -3. Okay, so if you plug in -3 in for x, and if you work it out, then that'll help you determine where to graph. All right. When you plug in -3, if you get a y value higher than 1/3, then you know that the curve has to be up here. If you get a y value lower than 1/3, then you know that it has to be here. Okay? So this one, for the sake of time, it does end up being in this region. Okay? Alright. Now, this one, this is an interesting case. Alright? This one actually crosses, it snakes here, and it actually crosses the horizontal asymptote. Alright? So it's going to look something like this. Okay, we're going to try to get a little bit more of an accurate picture. So something like that. Okay. I'm going to come back to that in a second. Alright? The domain is going to be all real numbers except for the asymptotes, right? So x is not going to equal -2 or 1/3. Okay. The range is going to be y values such that y, that's x does not equal, y does not equal 1/3. That was our horizontal asymptote. Okay. Okay, so if you notice this, this remember pops up, right? This is in your notes also. A graph, a curve may cross a horizontal or oblique asymptote, all right? To find this point of intersection, if it does exist, all right, we're going to set the function equal to the horizontal asymptote, right? So the setup I'm going to do here is, and I'm going to choose purple, right? I'm going to set my horizontal asymptote, 1/3 is equal to the original function given to us. Okay. All right. I'm going to use some algebra solving skills. I'm going to cross multiply, right? So I'm going to get 3x squared plus 5x minus 2, because that's just equal to 1, right? Equals, and I know I'm going to have to distribute this 3 to the x squared minus x. So that's 3x squared minus 3x. Okay. And 3x squares would cancel out, right? Then I'm going to subtract negative 5x, negative 5x. That's going to be negative 2 is equal to negative 8x. And x is going to turn out to be positive 1/4. So look, if you, this means that the point of intersection is at 1/4, comma 1/3, right? 1/4 is the x value. The y value is 1/3. That's where the horizontal asymptote was. Okay. And so the point of intersection is right here. All right. Now, if it didn't exist, then you would not get an x value here. It just wouldn't work out. All right. So hopefully that was clear on how we did that. All right. If you need to rewind it, yeah, I would definitely do that. All right. So second to last example we're going to look at. All right. I don't think we're graphing these, but we're just going to fill all this out. All right. Vertical asymptote, it's already factored for you, right? That's going to be at x equals 1 and x equals negative 4 because we solved these factors in the denominator. The horizontal asymptote is y equals 0. And how do I know that? Because if you were to multiply the denominator, we know that that's going to be x squared, right? And so the degree up in the numerator is less than the degree in the denominator. And so we said the horizontal asymptote is going to be y equals 0. Okay. Oblique asymptote, there's none. There's also no whole because none of the factors canceled out. The y-intercept, okay, we know that that's going to be x equals 0. And when you plug that in, all right, you end up with negative 3/4. Okay. For the x-intercept, right, we said we're going to set the numerator equal to 0. Okay. Because your y value is 0, right? So that's going to be 2x plus 3 equals 0, and x is going to equal negative 3/2. So negative 3/2. All right. The domain comes from using the information from the vertical asymptote, right? It's going to be x such that x cannot equal negative 4 or 1. All right. And the range, okay, is going to be all real numbers. All right. It's going to be all real numbers here. All right. And the reason for that, right, is because normally the range would be, all real numbers except for whatever your horizontal asymptote was, right? But look what happened in the x-intercept, right? We actually have an x-intercept at -3/2, 0. And so there is a point, right? There is a y value there. So that's why it's all real numbers, okay? And let's look at this last one here. All right, so this last one in the numerator, I'm going to factor. So that's going to be 7x, right? That's going to be 1 minus 4x squared, okay? And down here, this factors to x minus 5 and x plus 2, all right? Well, I'm also going to notice that here, this is a difference of squares. So this actually factors more to 1 plus 2x, 1 minus 2x. And this would be 3x, x minus 5, and x plus 2. Okay. So my vertical asymptotes come from the denominator. Now, I want you to notice something though, right? This x and this x cancel out, right? So there's actually going to be a hole at x equals 0, all right? So I'm going to keep that in mind. The other two are going to be the vertical asymptotes at x equals 5 and -2. For the horizontal asymptote, right, this is going to be, the degrees are the same. This is x to the third, and if you multiply 3x inside, that's going to be 3x to the third. Okay, so the ratio is going to be y equals -28/3. All right. Since there is a horizontal asymptote, then there is no oblique asymptote. All right. For the whole, right, we said that it's going to be at 0, but 0 where? Okay. So what we're going to figure out, all right, is you're going to plug in 0, but into the reduced, simplified version, right? So in this version, I'm writing this down, all right? When we figure out the location of the hole, you're always going to use the most simplified version, all right? And so just for the sake of time, when you plug in 0 in here, you get -7/30. All right, so that's where the hole is, okay? Y-intercept, we know x is equal to 0, all right? But we already, right, we just said there's a hole at 0, -7/30. If there's a hole, then there's actually no y-intercept, so there's none, all right? For the x-intercept, we know that that means y is equal to 0, right? And so I'm going to take my numerator, my simplified numerator, and I'm going to set that equal to 0, right? And this you end up just solving for each of these parentheses. And so you get x is equal to -1/2 and +1/2. All right, so there are two x-intercepts, right? At -1/2, 0 and +1/2, 0. Okay. So your domain is x such that x cannot equal -2, 5, those are from the vertical asymptotes, and also 0 because at 0 there's a hole. All right. So, if you need to go back and rewatch some of this stuff, please do. If we need to review a little bit before class, we will certainly do that. All right. Let me know if you have any questions.